Question number two came in JEE Advance 2019. Here we have a rather straightforward question that you have a hole in the shell whose area is given to you, whose area is provided, and depending on that, you have to answer these particular questions: that what is the potential at the center of shell, what is the magnitude of electric field. So I'll give you a brief explainer that okay, how this question will proceed. What we are going to do is that we are going to write the charge dq as sigma dA, where dA is the area uh, given to us. This is the small charge basically which is removed from the sphere. Now whatever charge is removed from the sphere, that will be causing a change in potential and change in electric field. So whatever potential formula which you have, that is somewhere the formula would be kq by r, or the formula of electric field is kq by r square. You can simply write the change in electric potential as delta v into q delta into delta q, uh, and similarly delta q is equal to delta electric field, change in electric field. So that is what is required. The electric field is reduced or electric potential is reduced, or the ratio of potential, and so on. So after substituting this basically whole expression will simplify. So it will simplify in the terms as is written here, the potential at the center of the shell. So basically this value, the potential at the center of the shell, this value would come out to be some alpha v naught after calculation. Magnitude of electric field, this would reduce by some alpha nu naught by 4r. And here again, uh, the magnitude of electric field at a distance 2r from the hole will be reduced by what value? Again, this would not match this particular value. The matching value which we'll get here is option C. So that is the correct one. So thank you for joining.